Hi and welcome to another video from Berkshire Guitar Amplifier Repairs. Stuart Smith here on the bench as usual, and I've got a lovely old 1973 Fender twin reverb. This is the silver face version with the master volume control. I've taken it out of its box. It's come in a non-standard box, so I'll show you that when I put the whole thing back together. And this has come in for a full refurb. So this is going to be quite a longish video because my intention is to take you through the refurb step by step and show you everything that I'm going to do on this amp. It'll take quite a few hours work. I'll condense it down hopefully to an hour or so's video, but I intend to show you quite a lot of detail. So let's not mess around, let's get straight into it and I'll show you what this is like from the top and from the bottom, and we can get started on the refurb. Okay, here we are, top side of the amp. Looking fairly okay, a bit dirty. It's got a quad of 5881s of motley selection in there. Not too bad condition, a little bit of rust on the transformers, but that'll be perfectly alright. And as we look along the front, we'll see a few of the knobs are looking a bit sad and chipped. There's one there, for example, with a big chip out of it. All needs a good clean up. Let's flip it over and see what it's like on the underside. I haven't looked yet, I've literally just taken it out of the case. I've just noticed this as well, where the cable comes out here. That's not safe, that will have to be completely changed. And I'd like to find out why he's gone for this arrangement here and not just put a proper mains lead in. Anyway, I'll probably do that last of all and get that sorted out. Actually, before we flip it over, I thought we'd just do a little bit more exploration topside by taking off the HT cap housing here and having a look. Okay, well these are the originals, Mallory's. Lots of dents in them for some very curious reason, and they don't look to be leaking, but I think we will do, it's time for a complete recap on this. These are absolutely ancient. Valves, we have, that clip's broken, so I might see if I can find a new clip there. We've got a 5881 Sovtech and another 5881 Sovtech. We're going to do a revalve, so I'll just give these back to the customer. This is a PV 6L6. Okay, there's not that much difference between a 6L6 and a 5881, and another PV 6L6. So we've got a pair of 6L6s and a pair of 5881s in there. Right, well, that's the end of those. What have we got under here? What do we have in the way of preamp valves? We have a Yugoslavian 7025. That's a low noise version of a ECC83, if I'm correct. A Brimar ECC83, that'll be ancient and probably very worn. Another Brimar, it says 6060 on that, I'm not sure what that is. 6060, okay, I'm going to have to look that up. It's probably an ECC83, almost certainly. Another Brimar ECC83, again ancient, well past their date. Another Brimar ECC83, and a Brimar, oh, 6C60 that was. I thought I didn't recognise 6060, but I think a 6C60 is, I'm going to have to look it up, I can't remember. It might be an ECC81. Well, I'll look up the valve contingency for this amp anyway, to see what it really takes. Okay, well I'm just going to leave all those out, I'm not going to do anything on this. I'll leave that off as well. let's have a look. May as well carry on running the camera and have a look underneath, see what's happening here. Haven't even glanced at this yet. God dear me, that is heavy. Here we go. Right, what on earth is this? Right. Oh, God dear me. Right, there we go. So, yeah, it's a bit little tatty in here. All original, I think. I don't know what this is. Okay, some socket. Don't even recognise what sort of socket that is. With a bit of orange tape on it. I've no idea where that's going. I'll have to find out where on the circuit that goes. So just having a little look along here then. I think I'll zoom in a bit and then just move the camera along as we move along so that you can see a little bit better. There you go. Right, so starting on this side, obviously the mains transformer, output transformers underneath here, mains voltage selector. I will probably permanently put that into the 240 volt setting. Then we have our output tubes, 1, 2, 3, 4. Someone has kindly put a 1 ohm resistor from the cathode to ground. The cathodes used to go direct to chassis. Someone's put a 1 ohm resistor in each one of those, and that allows you to measure the bias current by putting a meter across there, and volts equals ohms. So if you had 50 millivolts across there, you'd have 50 milliamps through the tubes. That's a simple way of measuring the bias current. I've got a bias meter, of course, so I won't really need that, but that's useful. What else have we got here? This very old diodes and their associated 1 kV capacitors. I think I'll probably change that entire section. This is almost certainly the bias diode here, but I'm not sure what that resistor is doing either. Why have we got a 10 watt resistor in there? Yeah, this is probably a dropper resistor from the HT down to the preamp level of voltage. So that'll be what that is. These two caps here almost certainly feed the grids of the two sides of the push-pull pairs. I will be measuring those to make sure they're not leaking, because any leakage on those puts some positive voltage on the grid and causes runaway bias voltage problems. What else have we got here? Has this got a tremolo? Yes, it has. So there's the tremolo cell there, look. That's a photo cell and a neon light, and every time the neon light flashes, flash, 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 the resistance of the photo cell goes up and down, up and down, up and down. That's like turning a volume control, and that's how you get your whoa, 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 whoa tremolo effect. That cell will almost certainly need replacing because the photo cells become degraded with time. Okay, all the resistors are original. They're all carbon film resistors. We're going to need to check the value of all of these and replace out of tolerance ones. More carbon film. We have some cathode bypass capacitors here, usually 25 microfarads, 25 volts, that sit in the cathodes of the preamp tubes. There's 1, 2, 3 of those. One there as well, I think. Yeah, 4. They've all got to be replaced because they're well past their sell-by date. What else can we see? Well, there's this. Yuck. That's the mains coming in. The neutral for the mains. Mains coming in on blue, going off to the power transformer primary. That's going to need all tidying up. Horrible. I might put a new mains cable in if that's what he wants to do with the amp. Right, so all in all, it's looking a little bit sad. We've got a couple more bypass caps here, 25 microfarads, 25 volts. They'll need changing. So there you go, that's a quick look over the amp really. Just wondering where to start on this. I think I think probably what I'd like to do is to tidy up this mains input so that we've got a decent mains input, get rid of all this dangerous stuff here. Then do the HT caps recap and change these diodes and probably these capacitors and see if we have HT negative bias voltage and a sort of fairly sensible HT down on the preamp side of things. In other words, get our DC voltages looking good to start with before we try and plug in any valves. I think I might also, I think I will also check the leakage on these, and also I think I'll do the 25 micros at 25 volts. I'll do a full recap on the electrolytics, check those values before we try and plug any valves in and get any noise out of it. So that's the plan. Let's get started. Okay, when I turned it upside down, this fell out. Literally fell out onto the bench, so I need to find out where that came from. It looks like one of the capacitors that does the tremolo. There are normally 3 of them to do the phase shifting, but I can't immediately see where that came out of. It just literally dropped out of the amp. So there's a fair bit of work to do on this amp. Right, I think we'll make a start with this mains side of things. By the way, I've just had a kind of epiphany about what this might be. This looks like a toggle switch base with all the bits missing. So this is just a switch. That's connected to that, that's connected to that when it's switched. So I don't know what that was doing. Maybe it's switching. It looks sort of original. Maybe to go over here or something. Not sure. These wires are the original wires. And that looks quite an old kind of switch base, so maybe that was a switch here or something. There's a bit of tape across the hole here. Anyway, we'll look at that later on. So let's have a look what's going on here with this mains. Right, well, that's the neutral for the mains transformer, and the live is going to the fuse. That seems sensible. And the ground is going to solder down to the chassis here. Right, so I'm going to make my life easy and retain this ground wire here to save me having to solder to the chassis. So we'll just chop that off. We'll tap into there. We can remember that that's the neutral, that's easy, and live goes to the fuse again, easy. So now we need to get this out. These are never particularly easy to get out, these. It's often a question of trying to sort of squeeze them with some pliers and then just push them out. Screwdriver. Sometimes you can just about get lucky sometimes with these. Oh, there we go. That did actually come out fairly easily. Right, good. We'll just get rid of that horrible arrangement. Don't know what that is. This nice little break in the cable here, no insulation. That's all very dangerous. I'm just going to chuck that in the bin. And I have a spare mains cable here, which I'm going to fit. We could probably reuse this. So I think it goes in there like that, yes. Let's have a go at reusing this one, why not? So we'll put that in through there. And through here, no, that's not right. This needs to go through here first. Then through here. And again, these can be a so and so can get into, or they can be fairly easy. So what do we want? We want well, we're going to have to extend these anyway, so let's not worry too much about that. So what I'm going to do is I'm going to take this over to my vise and just squeeze this together. Otherwise, absolutely no hope whatsoever of getting that into the hole. Okay, so that's crushed up in the vise, and if we're very lucky, this will go in here. There we go. God, good, we got lucky there. So that can sometimes be extremely difficult to do that, but that crushing it in the vise trick is a good one. Right, so now I need to extend this red one over to here. This blue one doesn't need extending, that can just go straight onto there, and we'll join this to here. So really it's just the red one that needs a bit of an extension, so let me do that first and get a piece of wire. Okay, I've got myself a suitable length of wire there, so I'm just going to make a simple lap joint here, that'll be perfectly alright. There we go. A little bit of sleeving. Good. And that can go over to here. Tin that one. That's to the mains fuse, switching the live off to the voltage selector, back into the relevant primary of the mains transformer. Good. Now we do our neutral. Yep, that's good. We'll cable tie this lot up later, but for the moment let's just do our ground, which is going to be here. Again, I think we can afford to lose a little bit of that. And sleeve that, so we'll tidy all that up at some point later. Do all the tidying up later on. So now we've got what a decent kind of mains input now, not that tatty old thing. Not that we're going to be plugging it in for some considerable time yet. Right, so the next thing I'm going to do is to flip it upside down, and we'll make a start on those HT caps. Okay, here we are. So I'm going to do these to 100, well, the 70 microfarad at 100 volts. This is almost certainly the bias voltage being developed here, that would be my guess. And here's a 100 microfarad at 100 volts. You can see how capacitors have improved over the years. But it gives us a slight problem in that it won't reach from this pin to this pin. So what I'm going to do with this one, positives are down, I want to remember that, positive, 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 positive. Got to watch these two, these are in series, so they are, that's positive down there and positive up there. Anyway, we'll do that. I'm waiting on those actually to be delivered, so we won't be able to do those today. So I think what we might do is just try something like this. We'll just snip, let's see if this works. My intention is to just maybe just bend this up like this at a right angle, and bend this up at a right angle. And then positive was down, so it's that way. So we're going to basically put the capacitor in there like that, and I think we'll just put a little bit of hot melt glue bit better. And now we can make a little kind of J hook here, like so. And here, like so. So that's the plan. I don't think that's too horrible. That was quite neat, I think. The only real alternative would be to try to source some really huge 100 microfarad capacitors, but it's not so easy getting exactly the capacitor you want, especially at a sensible price. I'm perfectly happy with that. I think that's quite a nice solution actually. I don't know what you think. Again, positive is down. Like so. And we're good to solder that. Great. Happy with that. That looks alright, I think. I'll check the value of these resistors in a moment. Right, now what have we got here? We've got 20 microfarads at 500 volts times 3. I have got 22 microfarads at 500 volts times 3. I won't tell if you won't. And I think I'm going to do the same kind of trick. All the positives are down. There we go. All those are out. Whilst we've got this disconnected, let's do the value of these resistors. See how much in tolerance they are, or out of tolerance. Right, so this should be 47k, 4k7. It's 5k1. This should be 1k. It's 1k. That's okay. I'm okay with that. A 5k. This should be 2k2. It's 2k2. So we're good with those. Don't need to change those. So I'm going to use the same trick here of making a little right angle bend in these leads here. There we go. Right, let's see how a typical cap fits in. Positives were down. So we're going to put one in like this basically. And yeah, that'll be fine. So let's put some hot melt glue on. This just stops the capacitors vibrating around. These are F and T caps, by the way, very good quality caps. I try never to use cheap capacitors in amplifiers, particularly electrolytics. There we go, nice and parallel. Have the legend up, look, so that the next person in here can see what value they are. And here we go again. We can just quite simply do all these. I'll just do this one and then I'll do the others off camera. I think you've got the idea. Like so. Okay, I'll do the other two and I'll rejoin you when I've done them. There we go, all three in. Looks neat enough, I think. Positive, 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 so we're good to go there. This one will be positive and positive because these two are in series in order to get the working voltage up. These are 285 volt capacitors at 220 microfarads. So in series there'll be 110 microfarad at 2 times 285, which I can't do in my head, for 560, 570 volts, which is fine. I've ordered some 350 volt 220 microfarad capacitors, so they will be even better in there. Right, so that's that. Question of what we do next, really. I think whilst I think about it, because I'm bound to forget, I'm just going to change this clip here for a new one. There we go. I happen to have one. Hope it fits. Yep, it does. Good. Right, there's not much more I can do top side now, so I think it's time to flip it over and maybe have a look at some of the capacitors underneath. Okay, here we go. So one thing I know I definitely want to do is to check the leakage on these two caps here. So I guess we could do that now. That's quite an interesting exercise. These feed the grids of the power tubes. That feeds one pair, that feeds another. The grid is taken to a negative voltage, minus 35, minus 40. That's called a negative bias. There will be quite a high positive voltage on this side of these capacitors. And of course capacitors, as you know, block DC, so no positive voltage should get through to the negative grids. But of course if these caps are a little bit leaky, positive voltage will leak through, raising the grid voltage, allowing a lot of current to flow through the power tubes and blowing them. So the word on the street is to check the leakage on these two on these two capacitors only. We don't need to worry about too much about other capacitors at this stage. I'm just going to lift one side of that. I think this is probably the easiest side of this one to lift. We also want to isolate it from the circuit. There we go, that was quite easy. Now to check the leakage of those, I'm going to use, well, I use a thing called a Mega, which can generate 500 volts DC and measure the current flowing through, if any. So I'll just go and drag that out of my dusty equipment shelf and we'll get that hooked up. Okay, let me show you how this works. I've put a 4.7 mega ohm resistor across the terminals of this, and when I press this button here it'll put 500 volts across there and measure the current going through it. It's meant to test insulation, so normally it would say infinite ohms, which is what we'd of course like to see. We don't want any current, but because this is 4.7 meg it should read 4.7 meg. And indeed the meter goes up to 5 meg there. So that's telling us it's 5 million ohms resistance there. And now we can with confidence clip this to our first capacitor here. And I'm going to put 500 volts across that capacitor and see if it's got any leakage. Here we go. Did a little flip as the capacitor charged and it's infinite resistance, so that's perfectly okay. No leakage whatsoever on that capacitor. So I would expect the other one to be the same. Here we go. Not bad for a 60-year-old capacitor. So check this one. Little flip as it charges up. Infinite resistance. No leakage problems whatsoever. So both of those caps are good. I don't like to just pile in and start changing caps for Sprague orange drops and that kind of thing. For two reasons. It's expensive and it affects the authenticity of the amplifier. And why change them if you don't need to, if they're perfectly alright? So we can now leave the authentic capacitors in and pop those back in. I'll do that off camera, won't take me a moment. Good, those two went back in perfectly, no trouble whatsoever. So that's another little job done. Now let's start tackling these 25 microfarads at 25 volts. Again, these are kind of 60-year-old electrolytic capacitors. They may be okay, but it's not worth taking the risk with electrolytics. Basically, an electrolytic capacitor has two layers of material with a wet, in inverted commas, electrolyte sandwiched between them. That is what gives it its dielectric properties, and that electrolyte dries out over the years and becomes ineffective. So again, I'm going to use the same trick as before here. I know a lot of people, well, some people watching this don't like the way I do this. They say you should put it into the tag board there. They may be right. I'm, willing to be wrong. There's certainly nothing wrong with what I'm doing here. And if I start heating up this and removing these, maybe I'm going to be disturbing some connections that we don't necessarily need to disturb. So this is the kind of hallmark of mine. Anyone who looks at an amp with this on probably know I've been doing it. Just make a little J here. We'll just do one of these, I think, so that you get the idea of how to do a smaller capacitor, and I'll go through and do the others. This is going to be a longish video anyway, so I don't want to make it too long if I can avoid it. Right, so we have our Legend upright, if we can, like not so easy. Well, yeah, we've got a choice between having the negative sign upright or having the actual value of the capacitor upright, but I prefer the actual value of the capacitor. We would like to assume we've got it in the right way. There we go, like that. Hold it down, and then with these smaller caps you can just wind this around here like that. And right, let's solder that one. Otherwise it'll fall off when we're trying to do the other one. There we go. Positive at the top and negative at the bottom. Now with that anchored, we can do this one. Crimp that in. So there's a mechanical connection there as well as a solder connection. This will last another 50 years, no problemo. Trim off the waste. That's alright. And that's one done. You can read a Legend and it doesn't look too bad. That's okay. So I'm now going to mush ahead and do another 1, 2, 3, 4, 5. Right, that's all the small caps done. 1, 2, 3, 4, 5, and a difficult to do one under there, 6. So I'm just waiting on those larger electrolytics, which should come in maybe tomorrow or the next day, and then we will have finished the capacitors. Whilst I'm waiting, I will probably now move on to doing these diodes. But I've had enough for tonight, so I'm calling it a day, and I'll catch you tomorrow. Here we are again, another day. I thought I would sort out this area today, make a start on this, and I'm going to swap these 4 rectifier diodes, which are doing the HT rectification, and these associated capacitors. They're probably all okay, but they are very old now, these old bead diodes, and these may have gone leaky, so I think we really ought to change all those. And I have some 1N4007s in stock, and I've also got some 3 kV 2 nanofarad capacitors. These capacitors are 2 nanofarads for some strange reason. Pretty much anything would do in there. And I'm also at the same time going to swap out this diode here, which is doing the rectification for the bias voltage. So that's what we're going to do. I think my plan of action here will be to make a diagram of this, which way around the diodes are, and then just strip it all out rather than trying to do it one component at a time. There you go, I've just made a little sketch of the layout here, just to make sure I don't make any mistakes when I put it all back together, so we can just copy this. So the next thing to do is just to remove all these components. Right, let's make a start on this. Shouldn't take too long. This one's being a bit stubborn. Okay. Have to be a bit careful with these. Sometimes they take the lead through to the other side and actually use that to solder onto on the underside. That doesn't seem to want to come out of there. I might just leave that in there. Yes, again, that one seems to be very solidly in there. I guess we may as well do these while we're at it. Good. That is that. Now we have to think how we're going to get the new components back in. They're not particularly easy, these little eyelet boards, so what I think I'm going to do is bend the diode to the right length, which is, I think, roughly about like that. Diode down into the eyelet board eventually, but I think I'm going to do this trick of effectively pre-soldering the capacitor across here, and then I can just put this down in. So let me make up one of those and show you what the idea is. Right, well, the plan is to solder this across here. So I think I'll just do something like this, really. Wind that round a couple of times. And same over here. Like that. And then we'll just solder it. So now we can trim off these capacitor leads to length. And we don't want all this, so we may as well just trim those whilst we're at it. And we'll just pre-tin these since we're at it here. And that is one of the components. So I'll make up the other 3 of those, and then we'll see about getting them in. Right, there you go. I've made up 4 of those, all ready to go in. So let's pop them in and see how we get on. So referring to our little diagram here, we'll do this one first. Make sure we get it the right way round, so we're looking to put this basically in here. Well, let's see how it goes in. Okay, very straightforward. Make sure we've got it the right way up. We have. And now let's see how easy it is to get a second one into that same eyelet hole. This is why I don't really like these eyelet boards. They're not terribly easy to work with, but I'm sure we'll get that in okay. Yep, that's alright. Good. Make sure this is the right way round. I haven't trimmed this one down or tinned it. Honestly, the production people here are hopeless. Quality control leaves a lot to be desired. Right, so is that the right way round? No, that's the right way round. Just always checking against my little diagram here. Yep, that's gone in okay. And the final one, which is this way around. All good. I'm not sure I even need to go over those joints. I think they're all pretty good. Ooh, isn't that pretty? Now the only thing left to do is to put our final diode in, this one here, which does the bias, negative bias voltage. Tin that. Chase it around. I find it easy just to hold it in my fingers actually. Perfected over many years. Like that, good. So the band is uppermost. This one goes into here. Like a so. Good. And that's great, that's done. So let's just double check now against our diagram. Okay, the bias diode band is up, correct. Now we go. Doesn't really matter where we start. Top one is left. Oh, good lord, I got that wrong. Whoa, would you believe that? I cannot believe I got that wrong. This is correct, band up. This is wrong. Ah, hang on. Ah, did I have the diagram upside down? I had the diagram upside down. These are wrong. How amazing, God. So careful there. My slight excuse is and it is a thin excuse that making a video at the same time as trying to repair the amp is slightly distracting. It just kind of takes your mind off, slightly off what you're doing and more onto, you know, has the camera got the right view? Can it be seen and so on? But I'm not buying that. I'm not buying that excuse. I think the person working on the amp's an idiot. Right, turn that, ouch, turn that around. This is why we double check though. You know, we check once, we check twice, we check a final time. Because it's just so easy to make a silly mistake like that, and that was a really silly one. Right, let's check again. Here's our bias diode, that's definitely correct. And now this is to the left, it is. This one is up, yes it is. This is to the left, it is. And this one is up. And like any good bridge rectifier, you should have two bands, two cathodes and two anodes. So this is the HT across here. We've got two cathodes and two anodes, and these should be an anode and a cathode, which they are, and that's where the AC goes in. Good. I'm leaving all the mistakes in. I'm not cutting anything out. I've decided now that the next thing I want to do is to power up the amp with no valves on and see if we get our HT here and our negative bias voltage here. That will show us that our capacitor change and the diode change has worked, and that we're getting the DC HT voltages we want. I'm still waiting on these two caps, but these will be perfectly okay, I'm sure, and we'll pop in the new ones when they come. So I've got the amp connected to the variac, and it's on. Come up quite a low voltage, that's 30 volts going in, and see if we're getting any DC at all. Oh, we are, that's looking good. Look, we've got 44 volts DC there, that's good. 44 there. Are we getting any negative bias voltage? Yes, we've got 5 volts or something of negative bias voltage too, so hey, this is looking good. So I think I feel confident to put a little bit more voltage in, and let's bring it up to 60 volts AC going in. 100 volts look DC, and minus 15 looking good. I'm looking for about, I don't know what this would be, minus 60 volts I would expect eventually here. There's no current being drawn, so I would expect all these HTs to be pretty much the same. Right, I feel confident to put 100 volts into this. Just winding up the variac off screen here. How are we doing? 200 volts DC. Fantastic. It's gone up a bit higher. 220 volts. And our bias is minus 26 volts. That's great. So I'm now going full voltage, and that gives us 465 volts there. These will all drop when the valves are in, because the valves will take some current and the DC HT will sag, so I'm not overly worried about the size of that. And here we have our minus 62 volts, you see, which is perfect for the bias. And on the HT here, 500 volts HT. Again, that will sag as we put some valves in. That's looking great. Hey, so that all worked. Well, I'm kind of tempted to put a set of tubes in this and see if we get any noise out of it, and if the power tubes bias up. I think that's probably the next thing to do. We've got a fair old bit of other stuff to do on this. It's useful just to see if the thing basically works, and how scratchy the pots are and all that kind of things before we take it further. We've still got work to do on the amp. So I've got a whole new set of JJ tubes here. So I'm just going to pop those in, and I'll put a couple of bias meters on the outside valves, and then I'll rejoin you then, and we can have a power up and see how we get on. Right, turn up again. This has come up. This is coming up here. Now, you almost certainly can't see that. It's so faint, the display on this. Anyway, we have some current trickling up here. Nothing on this one yet. We're at about 125 volts in. We've got 3 milliamps current on this valve here. I'm just going to come up a little bit more in voltage. See if I can encourage this one to get enthusiastic. It is coming up. It's 2 milliamps, 3 milliamps, 4, that's looking good. This one's at 7, this is at 4. So we've got a little bit of bias current there. We've got 141 volts AC going in. Just possible. Oh, I can hear something as I turn that volume control. Scratchy, scratchy, scratchy. Great. Just possible we may be able to hear something. So if I... Oh, whoa, would you believe that? That is actually working. How nice. And we've only got 7 milliamps on the bias. We're only on 141 volts going in. So I'm going to turn this up a bit to a couple of hundred volts. So we're up to 200 volts going in now. 431 plate voltage, 16 milliamps on this valve, 20 milliamps. You may just about be able to read that. It's a hopeless meter, this. Yeah, you just about see that now. 20 milliamps on this one. All looking very good, this. Let's go to full voltage. It's even biased roughly correctly. Amazing. Right, we've got 500 volts on the plate and 28 milliamps here, 22 milliamps here. So there's a slight mismatch, but I'm not worried about that for the moment. The bias is approximately correct. Right, that's good. So what I'm now going to do is to swap these two valves into the center position, which will just prove that the circuitry associated with the two center valves is also correct. Turn it on again. Right, so again we've got 21 milliamps here, and this one is coming up slowly. You see in the dark there. God, that's so dim. I'd like it to be twice as bright as that Euro tubes, please. 27 milliamps here, 21 milliamps on here. So the middle two positions are good as well. Right, now I don't think the vibrato will be working, just because of that capacitor that had fallen off. Let's just, for the sake of argument, plug it into the vibrato channel. This will actually tell us if the vibrato channel is working. There we go. Right, so yes, vibrato channel's working. Obviously we have scratchy volume controls. All these controls need all these controls need sorting out. There's no vibrato. So I suppose we could check. I think this has a foot switch, doesn't it? Let me just check that. I've connected a little phono plug to the foot switch for the vibrato, and when you short this, I think vibrato should come on, and shorting it has no effect. No. Okay. So that needs sorting out too, so I think we'll turn off. My guess on the vibrato is that capacitor that had fallen out is the culprit. I did have a quick look to see if I could see where it had possibly come from, but it wasn't obvious. Also, there are a lot of different versions of this amplifier, so it's not just a simple question of looking up the layout for one. I'm just checking now to make sure these caps are discharged, and they are. Look, just got 2 volts on there. 2 volts, that's fine, so we're all safe. And now I'm going to take the power valves out and flip it upside down again, and I think the next job is to sort out the vibrato. The reverb also doesn't work apparently on this amp. Actually, why don't we check that? I think I'll do that next. I'll just plug in the reverb tank and see if we can get anything out of the reverb. Okay, I've connected a dual phono lead to the reverb send and return. The easy way to check the reverb is to first of all see if the return is working. So I'm going to turn the reverb volume up, which is this one here, and if I touch one of these we should hear a horrible buzz. Ooh. So it's that one there. Quite surprised it's so horrible as that. But anyway, that means the effect that the reverb return is working. So I'm going to remember that this white band is the reverb return, and I'm going to get myself a reverb tank. Here's one I made earlier, and take the output of it and connect it to here. And we should hear a horrible clanking sound as I... and we do. So the reverb return is working fine. Is the send working? We'll just plug that in there. Turn up the reverb full, and that's actually working. Awesome. That's great. Well, that's a bonus. The reverb is working. That's not the correct tank, of course. Ooh, this is good. Well, fortunately I have the layout diagram for this amplifier. So on the actual board we're looking for a 0.02, which is 20 nanofarads off the end of this 220k, a 10 nanofarad after that, and a 10 nanofarad after that between these two 1 meg resistors. So let's see what we've got. And here is the 220k resistor. This is a 0.022 off the end of it, as we looked for. A 0.01 disc look going from there to there, and then there should be a 0.01 disc between here and here, between these two 1 meg resistors, and it isn't there, and that's where that little chappy came from there. I'm hoping that if we put the capacitor back in, that the vibrato will spring to life. Now this one is too far gone really. I could rescue it if I absolutely had to, but I'm going to put a brand new one in. And the last one I've got, which is good, at 10 nanofarads, 3 kV. These are only 1 kV. So I'm going to pop that one in there, and then I'll rejoin you when I've done that. Alright, there we go. I've popped that capacitor in there. I think I'll now flip it upside down, or the right way up I should say. Alright, let's get some valves in, and then we'll do a power up. Right, here we are, moment of truth. And let's turn on, see if we can get a basic sound from it. Let it warm up. I can hear it warming up, that's good. Can't hear any telltale thump 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 from the tremolo, so that's not promising. Let me just check that the intensity is up. Yeah, the intensity is on full. Well, maybe let's try. Okay, no vibrato there. Let's try shorting this together. Oh, whoa, whoa, whoa! Oh, wow! Oh, wonderful! Listen to that. Oh, beautiful tremolo on these amps. These are the go-to amps. The trouble is they weigh an absolute ton. Well, I'm absolutely delighted with that. To be honest with you, I didn't expect it just to spring to life like that with putting that capacitor back in. And we don't have to change the tremolo photo cell because the depth on that is perfectly good enough. Time for lunch, I think. What do you reckon? I think I deserve it. I've been all morning on the amp. I'll catch you after a little bit of tiffin. Another little job I want to do is to bypass this voltage selector switch. Talk about a disaster waiting to happen. It's actually a rotary switch on the back which you can turn and select the input voltage you want. Slightest knock on that, or that accidental selection of 120 volts, and this amplifier is completely destroyed. This is not going to be going off to America, so what I'm going to do, here's the input to the fuse holder. Just going to cut that there, and here is the winding we're interested in, the 240 volt winding. So I'm going to cut that there, and I'm leaving these tails on the switch here so that if anyone ever wanted to restore this, they could easily see what I've done here. And I'm simply just going to connect this to here permanently so that the mains input selector is bypassed. So let's do that. There we go. So I'm just going to solder those two together with a bit of sleeving. I won't take up your time watching me do that. Okay, there we go. I've made that connection permanent. I do want to check though that I have got the correct winding. Well, the easiest way is just to measure the HT. Still not sure what this is flapping around here. I haven't got the exact layout for this model. We got a bit lucky when we did the Tremolo circuit, and in that the layout I had was correct for this. But when I went to look where this was attached on the board, it wasn't the same layout. So I'm going to have to do a bit more work on what this is. Some sort of switch that was there. I'm sure all will become obvious at some point. So, right, so the technique here is to plug it in, put it on the variac on a low voltage, which I've just done, 40 volts say. So I'm pretty confident this will be right, but let's, sorry that'll be at a bit of an angle for you. What have we got on the HT? 50 volts, that's okay. Let's bring it up to 100 volts input. 200 volts on the HT, looking good. Bring it up to 200 volts in. If that winding selection was wrong, we'd have way too much voltage here on the DC side of things. Carry on, we've got 200 volts going in, 325 on HT. Let's go full power. 400 volts there, that's good, and the actual HT will be 500, I guess. Yes, it is, yeah. Good, so we're good to go there. I did very carefully check that I got the right winding on that switch, because obviously that would be a disaster. We'd cause the problems we're actually trying to avoid. So that can go off. There's the switch, look, absolute disaster waiting to happen. So I just knock on that. How many amplifiers must they have destroyed before they got wires and at least had that plug, unplug kind of thing that you unplug, rotate, plug back in again. This is so, it's even got a handy lever here so you can just knock it without even thinking about it. Absolutely terrible idea. Who thought of that? Thought that would be a good thing to do? I mean, really, 5 minutes thinking on that would have you say no. The tiniest knock on there, and you've deselected the voltage. Ugh. Anyway, there you go. That's completely bypassed now, that switch. Now another little job is, I notice there's a bit of tape stuck over here, and when we pull it off it says on, so this is where the main switch, the mains on off switch is, and it's missing for some very curious reason. Standby switch is there, the mains switch is not. Let's flip it over again and have a look what's going on there. So normally you'd expect to see the mains coming in alive. Obviously, if you remember, this is the wire we added. I'd expect to see it go through the mains on off switch first of all, which would be there, and then back out of there into the fuse, out of the fuse and off into our primary of our transformer. But there's no on off switch here and no sign of how that was actually fitted, or nothing obviously missing. Anyway, I think we definitely need to fit one. Can't imagine why you'd have an amp without an on off switch. Well, hello again, it's been another day and I'm back on the amp again. I want to solve the mystery of this floating part here on the end of these cables. Now it's original because I can just tell from the cables, all these cables are of the same vintage look, so this isn't any kind of modification. I've spent quite a lot of time, I've got various photographs of amps I've worked on in the past. They're all different, of course. By that I mean all the Fender twin reverbs I've got are different. But I did manage to find a photograph which looks a bit like this shot here. A still photograph of an amp very much like this, and I was able to see this cable here going along, and this, of course, I was right about it being a switch. This has come off the back of a volume control, so on my photograph it kind of looks like this. I don't know what it does, I'm going to need to look that up. It's a bit strange really, because one of these goes off to this white wire goes off to the Reverb phono input here, and the others go to the middle of the board here. In fact, it shorts this resistor here when the switch is closed. Again, I'm not quite sure what's happening here. Can't imagine why you'd want the reverb input signal switched. Very weird. But I think what's happened here is, don't you think that pot there looks a little bit newer? The other pots, don't you think that looks quite new compared to these rather dirtier looking ones? Don't know if you agree with me there. I think it looks a bit newer. I think someone has replaced, also the knob doesn't look kind of great, does it, on there? So I think someone has replaced this pot, and they haven't been able to get a switched part. I think obviously you either turn this or pull it to switch something, and so they've just wrapped this up in orange tape and dumped it on the inside. So I'm going to next find out what that switch is supposed to do, and then see if the customer wants me to try to restore that. Won't be easy to get a switched pot like that, but anyway, we are at least on the track here of what's going on. Alrighty, praise the Lord for the internet. I managed to do some more research, and this is a silver face twin reverb, of course, with a master volume, which is what this is, and it did have a push switch on it, push to switch, push back to switch off, and it was a boost function, so pull to boost with a bit of distortion, I think, and push to get rid of that. On the forums apparently it's hated. Nobody liked the function, and I've looked at the schematic. The schematic's weird. It does do exactly two things as I thought. It short circuits the reverb send, in other words a signal going off to the reverb pan, via a 1K to ground. No idea why, not sure what that's doing. And it also adds a bit of treble boost down here in the circuit. It opens short circuits and open circuits an extra capacitor, so it's basically just a little kind of pull to boost. I'm glad I've sorted out that mystery now, and someone obviously has replaced this pot, couldn't get a switched one, and just dumped this function. I'm just waiting now to hear from the customer whether he wants me to try to restore this. I'm going to try to dissuade him from that, or just leave this hanging around inside. If I do leave this hanging around inside, obviously I will insulate it, and I think I'll put a little note in saying what it is in case someone in the future does want to restore that to stock. So through the post this morning I had a nice toggle switch, so we're going to fit this in the off-on position on the amplifier. The customer said it never had one when he bought it, so that's pretty strange, but anyway, there's a hole for it here, so we're just going to fit that, and then I think I'll also put this little off-on decal on there. It's not very authentic, but I don't think it matters that much, so we'll put that on and just give that a little tighten up with the spanner. There we go, one off-on switch under here, you can't see it. Now we're going to wire it in, not too difficult, but you may not know exactly how to do this. The correct way to do it is to have the mains live input here, which is coming in, At the moment it's going to the fuse and then back off to the primary of the mains transformer. We don't want it to go to the fuse, we want it to go via the off-on switch, then via the fuse, then off to the mains transformer. So don't do it this way, don't have it coming into the fuse, out of the fuse into the off-on switch, out of the off-on switch into the primary. That will give you the same effect, it'll still work, but what that means is when you switched off, the fuse is still live. In other words, that point would be live, and so would any screwdriver you put down there or end of fuse you manage to touch. It's a minor thing, but it's just, I like an amp when it's off, it's off. It completely removes the live from any part of the circuitry, so this is the correct way to do it. So we'll do that quickly now. I'll just desolder this. Don't need this anymore. I think I'll just lose this piece of wire altogether. There we go. And we'll put in a new piece, so we want to go from here to, say, here. Let's go on to here. If you're a purist, you put some sleeving on there, but it's completely pointless. This HT switch has got 550 volt DC on it, and that's all hanging there, open. We've got this is live, that's live. There's no point in sleeving one terminal and leaving a dozen others unsleeved. And we want to go to here. It's a little bit long at the moment. We'll just chop that. Then I'm just going to sleeve this and solder it to here. Right, there we go, that's done. We might put a little bit of might put a cable tie around here actually when we're done. Now we're going to come from here to here, so we want something about this kind of length. Come on, doesn't want a tin. Okay, this can go onto here, and then onto the fuse. We'll just quickly tin that. There we go, that's the job done. So we've got an on-off switch now. We can try that in a moment, but I think I'll just get a couple of little cable ties and tidy this up. It's all floating around a little bit. One here. No, don't think we need to do anything else there. I think we will just try it, obviously make sure it does work. There we go, and well, it's off at the moment, so that's right, it says off. I'll turn it on and the light should come on. It does, so our on-off switch is working fine. Great, that's another little job done. I'm still waiting for those two big electrolytic capacitors for the smoothing side, and then we're getting quite close to finishing this amp. We need to check that the reverb pan will work in close proximity to this chassis, which it is in the box that the guy has supplied, but we'll deal with that later. I want to get the thing actually fully working, then we can worry about reverbs. Okay, our new 220 microfarad F&T 300 volt caps have come in, so I'm going to replace those as the next job. Like so. Put that there to remind me which way round it went, because these are in series, these two caps. So let me see, what do we want here? I think a bend there. about here. No, it's not. Okay, that's good. Yep, no, happy with that. Let's take, got that the right way around as well. Yep, positive down, that's good. Now let's take this one out. It's not particularly easy with these wires all hard up against the solder joints here. There we go. And I'll put that on there to remind me which way it goes. Just going to run a little bit of hot melt glue underneath this. There we go. Yeah, that's good. And there we go, that's the recap done on this. We can now put the top of this back on, and we're finished on that. Right, the next thing to tackle is this master volume here. This used to go on the back of here. This is the push-pull switch arrangement. Someone's changed this pot at some point. Let's just pop this off of here for the moment. I did manage to get a replacement pot from Hot Rocks. It's obviously not the same pot, but it's the right value, so we're going to try and put that in here and see if we can resurrect this. I'm not convinced we can, but we'll give it a college try. Right, the first thing I notice is that this shaft is really loose in the hole here, which is kind of what I feared. The old shafts were a bit bigger. Anyway, that's the same diameter shaft as this new one. Yeah, it really rattles around in there. Yeah. So the problem we've got is that the hole here is a lot bigger than the shaft of the pot. I'm just going to have a go at putting this in here just to see if we can get anything vaguely satisfactory. It might be good enough. I think that'll be alright actually. Now it's got the push-pull function. Right, I've got it all connected up and a guitar in, so we'll power up. I've just had it running, so it does work. I've only got 2 output tubes in at the moment. So that's fine. This does nothing. There's a bit more noise on the in position, a bit hissier, but I can hear no tonal difference at all. Quite literally nothing. So I've read on some forums that people don't really know what this is supposed to do, and it doesn't seem to do much, so I think I'm just going to leave it alone really. So the next thing to do is to get the other pair of output tubes in and make sure that's all okay. Righty-ho, the next job on this is to get the reverb pan working. Now I've got a brand new reverb pan here and a brand new set of reverb pan leads which I've connected up here. The amp's all connected up and we've got a nice bathroom effect there. Right, now I haven't shown you this yet, but this amp goes in a custom made wooden box which I think the previous owner made, because the original Fender cab was completely trashed apparently, not sure what happened to it. So the customer wants to reinstate the reverb, but we don't have much space. The top of the box is about kind of here, with about maybe, I don't know, that much clearance from the top beneath. So we do have space to put the pan here somewhere. However, you have to be very careful with reverb pans close to mains transformers. And I want to just make sure that we can put this in without picking up a lot of hum. So for example, this side here is the out, and if we bring this near to the mains transformer, look, I'm sure you can hear that. So we can't put the reverb tank here. However, if we turn it round, you see it's nice and quiet, because the coil from the reverb tank is on this end here and it's away from the mains transformer. So we want to put it in this way, and to remind myself about that I'm going to mark up. Right, there we go, I got the chassis and the reverb tank in here, and it was a right flipping mission, I don't mind telling you. I had to have 4 goes at taking the chassis out and repositioning the reverb tank. It absolutely has taken me hours to get that sorted. Anyway, there you go, a bit of a weird one this, isn't it? You know, a bit of a homemade case, but that's okay, it works alright I'm sure. And I'll just show you the other side. Okay, here's the rear of the unit, and the reverb tank's down there on the floor. And you can see there's very little clearance between it and the valve there. And of course it's as far away from the mains transformers as possible, and the output of the reverb tank is at this end, not at this end. So I'm hoping that will be alright. Won't get too hot, I hope. We'll just have to see really. It's a bit of a lash up anyway, so we will see how it goes. Well, there you go, quite a project that. I don't mind telling you, I'm sort of fairly glad to see the back of it. It's been kicking around the workshop for best part of a month now, waiting for this or that bit. And I don't like having amplifiers in bits up the corner of the workshop, because I forget what I've done on it, and I can't just lose the plot on that particular amplifier and I have to pick it up again and start again. I like to just repair an amplifier and that one's done, and then do the next one and get that one out. But not always possible. So anyway, obviously a fantastic amp, lovely, and it's good to go now for a few more years. We've got the reverb tank in just. That was a right flipping job getting the reverb tank in. Anyway, hopefully that'll be okay, and yeah, hope the customer will be pleased with it. Onwards and upwards, on to the next one, and thanks for watching as always.